I'm going to be talking about compliance and regulatory standards and why they are in no way incompatible with modern development best practices. For those of you who don't know me, my name is Charity. I am the co-founder and CTO of Honeycomb.io. I co-authored database reliability engineering and observability engineering. If you happen to have a hard copy, I have sheets of stickers that you can decorate your little wolfie with. Now, my background is not in security. This is the first and will be the only security-related talk I ever write or deliver. Are any of you security experts? No? Excellent. One. Fantastic. We outnumber you. Normally when I'm giving talks, it's about things like this. High-performing teams, or continuous delivery, or debugging, or on-call, or testing in production, or anything that has to do with observability. And over the summer, some of our biggest customers at Honeycomb are from fintech. And they're like, we're throwing a conference. It's called FinTech DevCon. And we really want you to talk about that stuff for heavily regulated environments, because we keep hearing that it's impossible, it can't be done. And I was like, great. And I overcommitted, and it took me a long time to pull this together. But I'm not sad, because I've been saying this on Twitter for like years, that like, someone needs to do this. I know it's not incompatible. And I know that there are people out there who are doing this, but how and why? So that's what we're going to talk about today. Now, when I'm talking about modern software development best practices, the things that I have in mind are, in particular, these things. Engineers owning their code in production, you build it, you run it. Practicing observability-driven development, you instrument, you understand your code, you test in production, you separate deploys from releases, and you practice continuous deployment, ideally, at least continuous delivery. And what all these things have in common is that they all individually and collectively cohere to create fast feedback loops. It's all about getting your code into production as fast as you can after you write it, and then verifying it, validating it, while everything's still fresh in your head, while you know what you've written, and you're making sure that your users are using it the way that you want it to. And these practices, like, they aren't brand new or anything. They've definitely gotten more mainstream in the past few years. But they aren't just like, buzzwords. They represent the best of the information and the experience that we have to offer each other in terms of best practices about how to be a good engineer, how to be a great engineer, how to be great engineering teams, and how to deliver incredible experiences for our users. So I'll briefly describe what I mean by each of these things. Engineers owning their code in production. I don't know if any of you were in the little podcast we were recording earlier today. I was talking about this a little bit too, how like in the beginning, like God created the heavens and the earth, and there were engineers, and we wrote code, and we owned it, right? You wrote it, you were responsible for it. It was a beautiful little feedback loop, even if we're all editing it in Vim buffers on production life systems. Stuff got really complex, and so we started to split those disciplines up. Some people would write the code, and other people would operate it and understand it. It was the best thing we could figure out to do at the time, but it was fundamentally a grave mistake, because it severed that beautiful feedback loop that, where the people who are writing the code are also being exposed to the output and the consequences and feeding that back to make their code even better. Systems are becoming too complicated now. I believe that if you weren't involved in writing the code, you're not going to be able to operate it well. And conversely, if you're writing it and not operating it, you're not going to do a good job of developing it either. So engineers owning their code in production is principle number one. Principle number two is we instrument our code as we go. It's not an afterthought. It's not something that is on the checklist of before we start selling this feature, we're going to add telemetry. Like, it can't work that way, right? As you're writing your code, you understand what's important, you know what's meaningful, and that's the time that you add your telemetry, right? And then you close that feedback loop by going and looking at it after it's been deployed and asking yourself, does anything look wrong? Like, is it doing what I expected it to do, and does anything else look weird? Testing in production, this is a little bit controversial, but it shouldn't be, because everyone does it. We all do it. The only question is whether or not we admit that we do it and build tools and practices to do it responsibly. Which means, being in constant conversation with your code. This is a big part of it, honestly. Separating deploys from releases using feature flags. Since the key to reliable software is shipping smaller diffs more and more often, this is not super compatible with the desire of product people and marketing people who are like, but we need to have releases, right? You can't just be constantly changing things under the hood. And they're right. We need both things, right? You need to be constantly shipping small diffs, and you need to be able to plan, releases and so forth. And the way that we do this is by separating them, using feature flags. This is also how we can do things like test in production responsibly by, for example, deploying your change, but constraining it, maybe to only internal users or only beta test users or only, some controlled demolition is one way to think about it. And finally, continuous delivery. This means no manual blocks or gates in the middle between you writing your code and it going into production. Honestly, ideally, this should be fully automated. In the ideal world, you write your code, you merge it, and it's almost like you assume that that's an atomic operation between when you merge the code and when it's live, because the robots take over, and they run all the tests, and they do the deploys. As fast as possible, as automated as possible. This is something, if there's one deep divide between people who really struggle in compliance environments and people who don't, it's the teams who have internalized the fact that your architecture does your security for you, and through continuous deployment, they're the ones who have it figured out. So, these are the things that we want. What's standing in our way? Well, I went on an expedition, and I'm going to take you on the expedition that I went on. Explain it to me like I'm 5. Security. Well, there's this holy triad of confidentiality, integrity, and availability. It's like the CAP theorem of customer data. You must demonstrate that you have policies, procedures, and safeguards in place to continue. This is what all of these regulations and frameworks are about. Regulations like GDPR, CCPA, PCI, all of the little local regulations, frameworks, SOC 2, FEDRA, etc. These are the big ones. Something I learned while investigating this talk is that these are different from each other. Regulations, if you're doing business and you're subject to the regulations, you're just subject to them. You just have to follow the law. There are not any audits for these things. And there's a lot of it that's just kind of best effort. There isn't a lot of legal precedent for a lot of the details here. Frameworks, on the other hand, you get audited for, which is why a lot of people will use frameworks and audits kind of as a twofer to ensure that they are following the regulations as well. But these aren't really the big deal, because there is nothing in any regulation or framework that tells you how you should achieve your security goals. It's all about outcomes, which is why when people say things like, oh, we're subject to SOC 2, so our developers can't deploy their own code, they're not talking about regulations or frameworks. They're talking about the written policies that their own security teams or legal teams have conjured to try and tell you how to fulfill. Aha, yeah, yes, thank you. I love it when people are like, yes, and I'm like, thank you. how you should go about complying with your regulations. Or, honestly, an even bigger problem is the contractual terms that your customers have made you sign. This is really the meat and potatoes of this. Like, for example, big customers, like enterprise customers, might say things like, okay, in order for us to sign this contract or DPA, you need to be scanning your code for known vulnerabilities before it's made live, right? The actual regulations don't get down into the weeds like that, but customers may ask for things that may or may not make sense. In this talk, I want to be clear, I'm not fucking around with FedRAMP. It's outside my scope. It's a whole different talk. Although I will say, that material does exist. If you look for stuff that Jez Humble has written and spoken about, really the entire existence of FedRAMP is a miracle and a marvel in and of itself. Anyway, frameworks are very loose on the specifics. None of them expressly forbid any of these nice things that we said that we want, testing and production, et cetera. Enterprise customers, contracts, implementations, et cetera, often actually conflict with each other. Like, one of the contracts will say, keep all logs forever, and another will say don't log anything. They may also conflict with your own customer contracts, yeah. There are a lot of terms in here, like, for example, business need. You see these all over the regulations, but they're not really defined anywhere. It's up to you to decide what business need means. Which is why I think we should, like, laws, yeah, you and me have very little chance of changing the laws on our own, but policies are living documents. Contracts can and should be negotiated. These should all be subject to regular reconsideration and review. And, like, engineering is usually not invited to the table when it comes to signing customer contracts, which is why we need to barge our way in and get a seat at the table. Because, honestly, we have a better idea of how to achieve these. Like, so much of the frustration around these things comes from all the security theater. It's like, that's what you want? Okay, but you're asking for this, and it makes no sense. You're just asking me to, like, Xerox a printout of a something. Like, what you want is an audit trail, then, like, invite me to the table. Let's figure out how to give you an audit trail that's actually secure, right? We need to participate in these. We need to participate, we need to advocate for our needs, because we can bring better solutions to the table. Compliance, like, these exist for a reason, and we're not trying to get out of them. We're not, the problem is that if we aren't there helping craft the solutions, we are less secure. The very first question that we should always ask is, what are we trying to do here? And we need to understand that really thoroughly before we even try to come up with a solution. Common objections that we hear at this stage are, we can't have continuous delivery, we can't do all these things because we're regulated. That's just a thing for websites and APIs. Like, we have too much legacy. The subtext of any of these is like, our people are not smart enough. Actual reasons are very different. Not only are these not good reasons, these are solved problems. This was a solved problem a decade ago. There are so many companies out there that are practicing all of these modern best practices. Many of them are probably your competitors. I'm going to move through these really quickly because I've got a lot of them. In fact, my project these days is collecting a slide for every company that's, like, practicing these things. So look, I've got a few. All these folks deploying many times a day, practicing observability-driven development. I want a slide from you too, and anyone else who's doing this. It's not hard. I mean, it is hard, but it's not technologically hard. But the first step is for us to stop blaming the regulations and the industries that we're in, because it is not their fault. This is all about how we decide to interpret those standards. And in fact, I think it's really interesting. Like, if you look at the language, I think engineers we're so literal, just so incredibly literal-minded. But most of this language, to the extent that it has legal definitions, it comes from accounting. Like, most of these terms are accounting terms, right? So that the thing that we've interpreted as you can't write the code and deploy the code, that actually comes from a policy from accounting that says that the same person shouldn't submit the request for reimbursement and do the reimbursement, right? Like, the policy is there and it makes sense, but they're using a language that's foreign to us, which is why we need to come to the table and not just take the literal definitions, but understand the intent and then help come up with a solution. It's not as simple as saying that every company can do this the same way either. Every situation is unique in the same way every architecture is unique. Interpretations will vary based on risk tolerance. The way that we at Honeycomb define business need is probably not the same way a major credit card company could define business need. Every single one of these is a little bit sui generis, but that doesn't mean we can't do it. It just means that we need to understand it. And the fact that we're so bad about sharing how we do these is why every single one of us has to keep reinventing the wheel at company after company. I think that, the security industry tends to be so tight-lipped, because we don't want our secret sauce and our, we can't let people know how we're doing things. And I think it's really holding us all back as an industry. And as engineers, like, we're engineers first and security experts second, right? I think we have a responsibility to each other to share our stories of how we're implementing these regulations and frameworks safely and securely to help bring up everyone's ability to do this well. It's a competitive advantage to ship fast. When it comes to architecture, the best place to start is, how long does it take you to deploy a single line of code? Because if you have to deploy the entire world to ship a single line of code, that's going to be pretty rough. Same thing goes to tests, right? The most important part of the architecture process is the beginning. You should always bring your security people in at the beginning when you're spinning up something new, when you're designing a new data pipeline, because that is where security is most needed. Design for testability, deployability, database, blah, blah, blah. This is all pretty table stakes. But in general, like, as engineers, we shouldn't need to be constantly stressing about regulations or thinking about security. It shouldn't, you think about it when you're creating something, but your internal compliance controls really shouldn't impact your daily work. Security should be baked into the architecture from the design stage. Because if you have to think about security and compliance every day as you're doing your work, that's bad. Because sometimes you're going to forget to think about it, or you're going to do it wrong, right? It needs to be baked into the process so that you're doing the right things automatically. The right thing to do should be easy. The wrong thing to do should be hard. You shouldn't have to think about this all the time. On the other hand, I think that engineering, performance, and productivity should always be on our minds, because everything's always getting worse all the time. Like, entropy is always happening, right? You're constantly accumulating. You spin up something new, it's shiny, hurry. You're constantly accumulating tech debt and baggage and, use cases and users and, disks are filling up. It's just the way it is. Entropy is always eating away at our efficiency, and which means that our productivity and our ability to get things done swiftly and efficiently needs to be continually renewed. If we want engineering excellence, we have to start engaging with security and legal as equal partners. I think that the ability of engineering teams to execute quickly, easily, swiftly, that is like the one job of engineering leadership, right? If we aren't there to do that, what are we for? And by that, I don't just mean managers or CTOs or VPs. Like every senior engineer, every staff, every principal, a huge part of your job is making sure that those around you can execute well. I talk a lot about CI/CD and high-performing teams, and it's like, we live in these socio-technical systems, and you can hire the best engineer in the world, if such a thing exists, onto a team where it takes you 2 months to ship a single line of code. It's going to take them 2 months to ship a single line of code, right? Your productivity tends to rise or fall to meet the level of the team that you join, because so much of your ability to execute is not data structures and algorithms. It's not the stuff in your head. It's the structure around you. It's the tooling. It's the patterns. It's the processes. And our engineering leaders need to understand the existential urgency of this and constantly go to battle for it. How well does your team perform is not the same thing as saying, like, how good are you at engineering? Like, when I'm talking about high-performing teams, I mean teams that get to spend most of their time solving interesting, novel problems that move the business forward. Lower-performing teams spend their time doing everything else. And if we're talking about what does it mean to be a high-performing team, I think, the DORA metrics are a great place to start. How often do you deploy? How long does it take for your code to go live? How often do your deploys fail? And how long does it take to recover from an outage? And I would always add, how often do you get paged outside of work hours? Because these socio-technical systems, people are a very critical part of them. And this is the metric that ties directly to people being exhausted and burned out more than any other, in my experience. It really pays off to be in a high-performing team. This is the difference between teams, between companies. Every company is a tech company now, right? This is the difference between winning and going out of business. 6,570 times faster lead time from commit to deploy for the teams that are high-performing versus mid-performing. And the way that we build these teams, is it hire the smartest people that we can? No, it is not. If you compare, the engineer on the left is on a high-performing team that deploys many times a day, and the person on the right is one that joins not even a low-performing team, but like median team that deploys every other month or so. Which of them is going to be a better engineer? Like, dramatically better engineer. Every time you deploy something, you're learning something. You're moving the business forward, which is why I really don't think of it as great engineers make great teams so much as the opposite. Great teams make great engineers. Everybody's always scurrying over and trying to hire all of the ex-Googles and ex-Facebooks and everything, but those people are not great distributed systems engineers. Like, they weren't hired at those places because they were great distributed systems engineers. They became great distributed systems engineers because they got to work on the biggest and best distributed systems in the world. Which is why, I guess I just said this, but like, when an engineer from the elite bubble joins a mid-performing team, your productivity rises or falls to match it. Your ability to ship code swiftly and safely is so much about the socio-technical systems that you are surrounded by. The smallest unit of software delivery is the team, not the individual. A person can't own something. That person has to go on vacation at some point, which is why the number one job, if you had one job for technical leaders, it's constructing and tightening those feedback loops at the heart of every system. Which brings us back to CI/CD. Shipping is the heartbeat of your company. It should be boring. It should happen constantly. It should be weird if it stops. It should happen automatically. When you merge your code, you should know that it's going to go out. It should be unremarkable. It should be a cadence that just happens. If you ask most people if they do CI/CD, they all say, yes, absolutely. Do you really? Often it comes down to, well, we definitely have a Circle CI account. Most people are doing continuous integration to some extent, which is good. But CI is really only, it's the prelude to the main course. The entire point of continuous integration is to prepare the path for you to do continuous delivery, at least, but better yet, continuous deployment. Bake it into your architecture, bake it into your system. It's so much safer for the robot to deploy automatically every time you merge your code than for another person, or even for you to have to go push the button. Continuous deployment, I believe this is a life-changing thing. And I believe this, I found this out accidentally. When we started Honeycomb, I'm the ops infra person, so I spun up an infrastructure, set up CI/CD, and got really bored hitting the deploy my code after like week 2, and so I wrote a little bash script and put it in a cron job so that once an hour it would look for any changed artifacts and just pull them down and deploy them if it found any. That little bash script, best piece of code I've ever written. Like, we just grew up that way. Code always immediately got deployed. You could just count on it. And, you know, it's definitely easier to start that way than it is to like climb your way up to there. But like, if you just can assume that your code is going out after you write it, it's amazing how many things just sort of like readjust in your brain. If you aren't going to hook CI up to production, honestly, why even bother? Just run it from your laptop. I don't really see the difference. Fear of deploys is the single largest source of technical debt in most organizations. And I don't mean deploys, I mean the fear of deploys. I mean the anxiety, the procrastination, the delay, the diffs getting bigger because people are sitting on them, code review taking too long, which is why, again, for like the 5th time, the job of engineering leadership is tuning the feedback loops or socio-technical systems, because it's the nature of a system, right? It's not static. It's flowing. It's constantly in motion. And that upstream moment when you've merged your code, built the artifact, that sets the high water mark for your entire team's performance. You can get worse after that, but you can never get better. And the reason that this matters so much, the reason that having that interval be short, which I know everyone intuitively agrees with, but I'm going to spell it out anyway, it's because that interval of time between when you wrote the code and when the code gets deployed is life. Like, this is what defines a high-performing team, is that you can get your stuff out quickly, because at that moment when you've finished solving the problem and writing the code, you have everything here. You know what you built, you know why you built it, you know what you tried that didn't work, you know what did work, you know what the functions are named, you know what the variables are named, you know what you're trying to do. And how long does that last? You're never going to know more than you do when you've hit that merge button and deploy the code. And it lasts for, I don't know, your memory might be better than mine, but like, mine never survives these switching projects, let's put it that way. You have to page a whole project in and out. You know, it decays, let's put it that way. We actually have stickers that say undeployed software ages like fine milk. You can find me or Martin afterwards. But that's why engineers, like, if we get disciplined about that, about having a short deploy cycle, looking at your code once it's in production, we can find, I did not pull this out of my ass, by the way. There's a white paper, Katie McCaffrey presented it, I should find the link. You can find upwards of 80% of bugs in that magical feeding interval, as long as you look at it. Is it doing what I expected it to do? Does anything else look weird? And I actually think it might even be more important that it be a predictable interval than it be super fast, because having it be a predictable interval means that, you know, you've deployed your code or you've merged it or whatever, and you won't feel done, right? In your body, you won't feel done until you've gone and looked at it in production. You know, 10 minutes, if it's 10 minutes or 30 minutes or whatever, you know your job isn't done until you've gone and you've watched users using it. Which hooks into, you know, the body's own reward system. You get those dopamine hits, the muscle memory, that feeling of, I'm done. I figured it out. I fixed it. You should never let yourself have that feeling just because tests run. It's not enough. The cost of finding and fixing bugs goes up exponentially with the time elapsed since development. You type your bug, you backspace, good for you. It's not going to get any faster than that. You run your tests, great. Gets into production. If you let it get past that point, it's likely to get very, very expensive in time and people hours. If it takes you a long time to get a single line of code out, I think of this as a software development dust spiral, because you get longer and longer intervals between when you've written it and when you're deploying it, which means you get larger diffs, which means longer turnaround time for code review, which means a lot more time spent paging state in and out of your head, which means, ooh, shit, now we get multiple changes starting to get batched up. Instead of deploying just your changes, maybe you're deploying 5 people's changes or 20 people's changes, who knows? Which severs that ownership that you feel over your code. If you're writing your code and you know it's going to be out in 30 minutes, you're likely going to go look at it. If you're writing your code and you're pretty sure that at some point in the next hour to week, your code might go out with 0 to 50 other people's code, you're never going to go look at it, ever. Why would you? You don't have ownership over that change set. Makes it really hard to identify whose code was responsible, which means that we spend more and more cycles waiting on each other. Soon we need specialists, SREs, build engineering, release engineering, people to do nothing but deploy and run and monitor and debug our code, which means more people and teams, which means more coordination costs, which means more people. All of which costs more and more time. And you can spend your life changing all of these symptoms and all of these pathologies, or you can fix it at the fucking source. I feel like an hour or less is really, really the limit. Fast cycle time, getting back to security stuff, is an enormous competitive advantage. I've never actually known a company where engineers were happy and customers were miserable, or where customers are happy and engineers were miserable. These things, they rise and they fall in tandem. If you feel empowered and you're creatively engaged in your work, your customers are likely to feel that. And if you don't give a shit, they're likely to feel that too. We can't do this because of regulations, is crap. Again, we can be very overly literal when it comes to this stuff, but we need to remember that we're not transcriptionists. We are here to interpret and creatively solve problems. You are the experts in software. They might be the experts in legal stuff or security stuff, but you are the experts in your field. And you are responsible, ultimately, as the closest to bits meeting disk, you are responsible for resolving conflicting requirements and for stewarding the health and performance of your own organization. Nobody's going to save your time if you don't do it for yourselves. There's no law or regulatory framework preventing us from doing this. We're all on the same side. This is very much about better security, not worse. Documentation is a huge part of what matters, so we can use this to our advantage. No surprises is really what auditors care about. You tell them what you're going to do, you do the thing, and you demonstrate that you did it. That's a huge part of what matters. A super boring example from Honeycomb. We used to manage AWS IAM roles using Terraform. So whenever we onboarded or offboarded employees, we had to remember to manually update a Terraform config file. Sometimes we'd forget. So we switched to a SAML-based flow that hooked into our Google account, which dramatically improved how quickly we could disable access for offboarded employees. But the auditors hated it, because we could no longer print out a config file listing all of the names with AWS access. Instead, we had to make up printouts of the SAML config code and a screenshot of the Google UI showing who had access. The auditors accepted it eventually, but it was kind of this weird case where us making things more secure felt less secure to them because it was less amenable to a manual auditing process involving PDFs of config files. Eventually, we added back in some kind of scripted way to print out the list of who had access, and they were delighted, although they had no idea how the list was generated. But like, right? Our North Star is protecting our users, protecting ourselves. Their North Star, they have a job to do that is meaningful, and we should respect it. But that translation layer, like, that's down to us. When it comes to driving change in your org, it takes time. It can take a long time at calcified organizations. Those are all out of order. But the way that we start, it can take years. If you have an org that's 150 years old, things don't change quickly. But it doesn't mean that it's any less important. Pointing out that competitors are doing things fast is a really good way to help spur change, which is why I'm collecting all of these slides, which you can find on Speaker Deck. But the way to get started is always by building relationships. Your peers in security and legal, they are being held responsible for all kinds of bullshit that you don't know about, right? You can just assume that that's true, because it's always true. So, like, someone has to take the first step. So make friends with them, understand their pain, find something that is meaningful to them where you can make their lives better. Then you can help them understand your pain and develop some empathy for you. You're not going to have a lot of luck without some cover from the top. The best thing that I can recommend is that you get everyone in your org, especially, I don't think there's any CEOs or CFOs or everyone should read Accelerate, right? Because it's one thing for assholes like me to stand up here and like wave my fist around. They collected data, a lot of hard data that shows the truth behind all of these things we're always talking about how the faster you can deploy, the safer it is, like counterintuitively. Like it's like riding a bicycle or ice skating, right? Where speed is safety. Being able to move swiftly and make small changes and adjustments is safer. It's better for everyone. But because we're mammals, like when we get scared, we tend to freeze, right? So it's counterintuitive to us that speed is safety, which means, we need to remember that and meet people where they're at. Also, this is a very important phrase, compensating controls, which means I'm not following the letter of the law, but I have this other system that proves that I'm following the spirit of the law. Instrument for observability. This is one area where observability can actually, engineers shouldn't need to be able to SSH into machines. You should be able to you should be able to understand your systems completely just having commit access and a good observability tool. Observability is what gives us the confidence to move fast. SLOs are another 2-fer, 3-fer, 4-fer, doing good SLOs checks a lot of boxes for us when it comes to executive visibility, monitoring, alerts. Instead of needing different systems for all these different things, SLOs are fantastic. And ultimately, did I not have a slide for this? Maybe because I learned this after I gave the talk. Ultimately, it really does come down to your architecture, right? You should have, think of the CI/CD pipeline. You've got multiple layers of checksums and static analysis, and so every time you deploy your code, all the things that they're talking about, the whole you can't write the code and deploy because you have multiple systems verifying each other. That's for the robots to do. That's not for us to be doing printouts. That should all be baked into your architecture. But ultimately, this is not just about the security or economic arguments, because your team's performance is defined by the speed of your feedback loops. Everybody wants to be on teams like these. All of us want to move fast. We all care about autonomy and mastery and meaning. We all want to have an impact in the world. We all want to see the consequences of what we've built. We all want to make a difference. which means this is a quality of life issue, I think, which means this is also an ethical issue. Like, we owe it to ourselves to build teams where we get to spend most of our time being creative and learning things and exploring and doing awesome things that surprise our users and make them excited. And that all of this begins with keeping your intervals low and your feedback loops tight. So, in conclusion, are we too busy to improve? The end.